Grid system and breakpoints. In this lecture we will learn about breakpoints and how to use the grid system. The breakpoints cover a handful of different device sizes and are meant to be used for mobile-first web development. Bootstrap is developed with the mobile-first web design philosophy in mind. This means that the layout first takes into account extra small devices like smartphones and then scale up the elements to larger devices like tablets, laptops and desktops as needed. Bootstrap is designed to accommodate 5 different device sizes, where the initial size is for extra small devices like smartphones. When we need to adjust our layout to larger devices, we can use 4 different breakpoints for small devices, medium devices, large devices and extra large devices. The 5 different device sizes have the following prefixes, which we will see used throughout many of the components and utilities later in this course. XS for extra small, SM for small, MD for medium, LG for large, and XL for extra large. The grid is wrapped in a container, which we just learned about in the previous lecture. Inside this we have rows which are made up of horizontal groups of columns. Content is placed inside columns and only columns may be immediate children of rows. There are 12 columns available in the grid, which means that the width of a column can be equal to one or more of these 12 columns. The 5 grid tiers are based on minimum width, meaning that they apply to the specified device size and all larger sizes. Column classes with device prefixes and numbers indicate the breakpoint and the width of the column. These features, plus other features of the grid, will be much easier to understand during the following examples. Grid system. We can make responsive grid using different classes, and we can make it look just like we want to. Here we see examples of the grid system being used. We will go through all of these in the code editor. You can resize the browser window to see how these works across different device sizes. Also remember that you can go into the practice section in your own code editor and add the different classes to learn how to use this. Alright. First we see that we have some custom styling in the CSS section, which is used to make it easier to see how these classes works. I'll just minimize this editor. And first we'll create our container, a div with the class container, and inside this a row which is a div tag with the class row. We will now create columns with equal width by using unitless classes for all or specific breakpoints. So we'll create a div tag with the class col, and we'll copy this twice. Now just copy the row and copy one of those columns here. Now we can see that we have equal width columns that will scale along with the browser window. Alright, to give a column a set width, we will add a number from 1 to 12 to the class. We can mix columns with equal width and columns with set width. So for example, we can add col 7 to second column, or col 3 to the first column here. Now we'll see that these will span 7 out of 12 columns here, and 3 out of 12 columns here, across all sizes. To give a column a natural width that fits its content, we use the class call auto. We can mix columns with equal width, columns with set width, and columns with auto width. Let's change this class to call auto. Now we can see that our second column in the second row only has the width according to the content inside it. The column to the left still preserves the 3 out of 12 width, and the column to the right has the width that's been left. If we want equal width columns to span multiple rows, we can divide them by inserting a div tag with the class W-100. So I'll just remove this and create 6 of these. If we want the row change to happen here, we'll insert this empty div tag with the W-100 class, which will give it a width of 100% and act as a divider. If we want the same grid across all devices, we will simply use the prefix call and call dash without any device prefixes. In our next example, we will create a row with 4 equal width columns and a row with 3 columns, where the first spans half of the available width and the last 2 each spans a quarter of the available width. So first a row with 4 equal width columns, and then a row with 3 columns, and the first one will span half of the available width and the last 2 will span a quarter of the available width. This will work across all device sizes as long as the content fits inside. We will now create an advanced grid that changes layout across different device sizes. To do this, we use the device prefixes. We want our first 2 columns in the first row to have full width initially by using the call 12 class, so no device prefixes. For medium sizes, we'll change it to half of the available width by using the class call MD6, and for large sizes and larger, we'll change it to a quarter of the available width by using the class call LG3. For our last 2 columns in the same row, we'll make them span half of the available width initially, so that is done with the class call 6. And for larger devices and up, we'll change this to a quarter of the available width by using the class call LG3. For all 3 columns in the second row, we'll make them span half of the available width initially, and then change that to a third of the available width for small devices and larger, using the class call SM4. So now when we look at our code or at our example, we can see the changes happening when we resize the browser window. We can set the vertical alignment on rows using flexbox utilities. To align the columns to the top of the row, we will add the class align item start to the row. To align the columns to the center of the row, we will add the class align item center to the row. To align the columns to the bottom of the row, we will add the class align items end to the row. You see the result happening instantly in the preview. We can also set the vertical alignment on specific columns using flexbox utilities. To do this, first need to remove these two and then add the class example align self so we can see this in action. Now to align a column to the top of a row, we'll add the class align self start to the column. And to align a column to the center of a row, we'll add the class align self center. To align a column to the bottom of a row, we'll add the class align self end. We see the result happening instantly in our preview. We can set the horizontal alignment on rows where the columns don't span all of the available width. I'll create 5 rows with 3 columns that each span 1/4 of the available width. Alright. To align the columns to the start, we'll add the class justify content start. To align the columns to the center, we'll add the class justify content center. To align the columns to the end, we'll add the class justify content end. To justify the columns with space around them, we'll add the class justify content round. To justify the columns with space between them, we will add the class justify content between. Now we can see these different kinds of alignment in our preview. If we want to remove the gutters between columns, we can add the class no gutters. Let's just do this for our last row here. Now we will see an example of how we can reorder our columns in a row. I'll just remove some of our code here. Alright, we will add the class order 12 to our first column to make it appear last. And we'll add the class order 1 to our second column to make it appear first. And we won't add any classes to our last column to make it appear out of order, which means it will appear first. We can now see that this is our first column that's actually appearing as the last one now. This is our second column that's before the other one. And this is our last column that's unordered, which means it appears as the first one. we can offset a column any number of columns we want and control it across the different device sizes. In our example, we will offset our second column in the first row 2 columns for medium devices and larger. So first we have a column spanning 5 columns on medium devices and larger, and we have another column with the same size, and this second column will offset that one with 2 columns using the class offset MD2. So what this means is that for small devices, those are just regular columns stacking on top of each other. For medium devices and up, we will see the width of 5 columns being applied and the offset of 2 columns for our second column, which creates this. In our next row, we will offset both columns, 3 columns for large devices and up. So we'll just create a row here. And then for large devices, we'll offset this 3 columns. And this one will also offset that 3 columns. So now we can see that those are stacked, but for large devices, we'll see both of them being offset 3 columns. And the first one having the size of 4 columns, and the second one having the size of 2 columns. We'll just create one more example. We'll create our row, and then we'll offset the column 6 columns for small devices and larger by using the class offset SM6. So we can see that initially it has the full width, but for small devices it will have the width of 6 columns and being offset 6 columns as well. Alright. We can also offset our columns using auto margins. So in our first row, let's use the margin left auto. We can see that it's now being pushed to the right by this auto value on the left margin. And we'll also exchange these offset classes with margin left auto for medium devices and up. We will see that those are being pushed as well. And finally, we'll replace this class with MLLG or ML SM auto. So you can use both approaches. Finally, let's see an example of how we can nest grids. Here we see two simple grids. We'll take the row from our second grid, cut it, and just delete this container class. And then we'll paste it inside of our first column in the first grid. We'll just create some line breaks and paste it in right here. Now we can see that we have a grid inside another grid. This will still act responsibly.